When parallel in conductors in the same conduit, derating for ampacity is necessary if the ambient temperature is expected to exceed 30 degrees Celsius, which is equivalent to 86 degrees Fahrenheit. This derating is essential to prevent overheating of the conductors, which can lead to insulation damage, reduced lifespan, and potentially fire hazards. The National Electrical Code, or NEC, provides specific guidelines and tables for determining the appropriate ampacity derating factors based on the number of current-carrying conductors in a raceway or cable and the ambient temperature. To effectively calculate the required ampacity, you must first determine the allowable ampacity of the conductor based on its insulation type and size, as specified in NEC Table 310.15. This table provides ampacity values for conductors at a specific temperature rating, typically 60 degrees Celsius, 75 degrees Celsius, or 90 degrees Celsius. It is crucial to select the correct ampacity based on the terminal temperature ratings of the connected equipment. Terminals are typically rated for 60 degrees Celsius or 75 degrees Celsius. Unless the equipment is specifically listed and labeled for use with 90 degrees Celsius conductors, you must use the 60 degrees Celsius or 75 degrees Celsius ampacity, even if the conductor insulation is rated for 90 degrees Celsius. Secondly, determine the ambient temperature. If the ambient temperature is higher than 30 degrees Celsius, you must apply a temperature correction factor. The NEC provides correction factors in tables accompanying the ampacity tables. These correction factors are multipliers that reduce the allowable ampacity to compensate for the higher ambient temperature. Thirdly, determine the number of current-carrying conductors in the conduit. The NEC requires ampacity derating when there are more than 3 current-carrying conductors in a raceway or cable. This derating accounts for the increased heat generated by multiple conductors in close proximity. The derating factors are specified in NEC Table 310.15b3a. For example, if there are 4 to 6 current-carrying conductors, the allowable ampacity must be derated to 80% of its original value. If there are 7 to 9 current-carrying conductors, the allowable ampacity must be derated to 70%. Fourthly, calculate the derated ampacity. To calculate the derated ampacity, multiply the allowable ampacity of the conductor by both the temperature correction factor and the conductor derating factor. The resulting value is the maximum current that the conductor can safely carry in the given conditions. Regarding achieving 600 amps in a single 3-inch EMT conduit, several factors need consideration. Firstly, determining the appropriate conductor size and quantity. Secondly, calculating the ampacity of each conductor. Thirdly, applying temperature correction factors. Fourthly, applying conductor fill derating factors. Fifthly, verifying that the final ampacity meets the 600 amp requirement. Sixthly, ensuring the conduit fill does not exceed code limits. Lastly, confirming that the equipment terminations are rated for the chosen conductor temperature. For instance, let's assume you plan to use 4 sets of parallel conductors per phase, plus a neutral, and a ground wire which does not count as current carrying. That gives you a total of 12 current carrying conductors. Furthermore, consider the ambient temperature to be 40 degrees Celsius. You decide to use 500 kcmil copper conductors with THHN insulation rated for 90 degrees Celsius. According to NEC Table 310.15, the ampacity of a 500 kcmil THHN copper conductor is 380 amps at 90 degrees Celsius. However, you must use the 75 degrees Celsius ampacity if the terminals are only rated for 75 degrees Celsius. At 75 degrees Celsius, the ampacity is 320 amps. Since there are more than 3 current-carrying conductors in the conduit, you must apply a derating factor from NEC Table 310.15b3a. For 12 current-carrying conductors, the derating factor is 50%. Therefore, the derated ampacity is 320 amps multiplied by 0.5, which equals 160 amps per conductor. Since you are using 4 parallel conductors per phase, the total ampacity per phase is 4 multiplied by 160 amps, which equals 640 amps. This exceeds the required 600 amps. Additionally, you must consider the temperature correction factor. For THHN conductors rated at 90 degrees Celsius, NEC Table 310.15b2 provides temperature correction factors. At an ambient temperature of 40 degrees Celsius, the correction factor is 0.91. Therefore, the temperature-corrected ampacity of the 500 kcmol THHN conductor is 320 amps multiplied by 0.91, which equals 291.2 amps. Applying the 50% derating factor for conductor fill, the final derated ampacity is 291.2 amps multiplied by 0.5, which equals 145.6 amps. The total ampacity per phase with 4 parallel conductors is 4 multiplied by 145.6 amps, which equals 582.4 amps. This is less than the required 600 amps. To achieve at least 600 amps, you would need to increase the conductor size or add more parallel conductors. For instance, using 600 kcmol THHN conductors, the ampacity at 75 degrees Celsius is 360 amps. The temperature-corrected ampacity at 40 degrees Celsius is 360 amps multiplied by 0.91, which equals 327.6 amps. With a 50% derating factor, the final derated ampacity is 327.6 amps multiplied by 0.5, which equals 163.8 amps. With 4 parallel conductors, the total ampacity per phase is 4 multiplied by 163.8 amps, which equals 655.2 amps. This exceeds the required 600 amps. Furthermore, ensure that the conduit fill does not exceed the maximum allowable fill specified in Chapter 9, Table 1 of the NEC. For a 3-inch EMT conduit, the maximum allowable fill is 40%. You must calculate the cross-sectional area of all conductors in the conduit and ensure that the total area does not exceed 40% of the conduit's internal area. If the conduit fill exceeds 40%, you must use a larger conduit or reduce the number of conductors. In summary, to determine the correct temperature range for derating wire ampacity when paralleling conductors in the same conduit, you must consider the ambient temperature, the conductor insulation type, the number of current carrying conductors, and the terminal temperature ratings of the connected equipment. The NEC provides specific guidelines and tables for calculating the appropriate ampacity derating factors to ensure safe and reliable operation of electrical systems. Always consult with a qualified electrician or electrical engineer to ensure compliance with all applicable codes and standards.